Hi, cut-induced throw. What is cut-induced throw, also sometimes called collision-induced throw? And why and when should you care about it? And then, what could you do about it? I'll try to at least begin to answer those questions in this series. This is a topic for players ready to take the next step up in shot-making accuracy. And I've developed some practice tools to help, so this is timely. Cut-induced throw means the object ball doesn't quite go where you expected. It's thrown a bit. Why? Friction. What happens when a ball is struck depends tremendously on how much friction there is between the ball and what hits it. Consider your Q-tip hitting a ball off-center. The ball goes in the direction of your Q-stick motion, more or less. That's because there's high friction. With slippery tape put on your tip, there's very little friction and you would miscue. It's like the ball bounces sideways off the tip. It's somewhat like when two balls collide. The balls bounce apart. There's very little friction between the two balls. Exactly where the balls go depends on their mass, the line of centers, and the friction. Here, we're concerned with the deviation of the object ball from the line of center's direction because of that friction. But because there's little friction, then there's a little bit of the ball, because there's a little bit of friction, then there's a little bit of the ball going in the direction of impact, like a cue ball going in the direction of a normal Q-tip hit, just a little. So the ball goes long by just a little. How much depends on the friction, and that depends on various factors discussed later. In the very worst case, it can be up to almost 5 degrees, but it's usually at 2.5 degrees or less. Let's look at some shots and see what it means. Here I have a ball hanging in a corner pocket. That's the target. I have a target ball shown on the distance spot, and I'm showing a 1 ball, which is where we go with 1 degree of cut-induced throw. Note this is a 5-inch pocket size. The 2 ball shows where we would impact it with 2 degrees of throw. Now 3 degrees of throw, 4 degrees, and 5 degrees. Now let's shoot the same ball to the same pocket, but this time as a back cut. We'll see the errors are to the other side. This is 1 degree off. I'm guessing this is all surprising to you. You know you're pocketing shots. You think you're going into the center of the pocket. So maybe this is all baloney. Well, I'd like to suggest an alternative. Maybe what you're doing is learning how to compensate for the average cut-induced throw on your average shot. But when you do something a little different, out of the ordinary, then you miss and probably don't understand why. Now from the head spot into the side pocket, here I'm showing you the target. Now 1 degree, we've been looking at absolute CIT caused angle error. But if we can learn the CIT error for a shot, maybe there's not really a problem. To consider this, let's look at the variation in CIT angle for shot variations. Let's consider the variation in CIT angle when we vary the cut angle. We probably don't transfer our intuition across cut angles, but let's have a look anyways. We'll check at 3 collision speeds for both stun and a rolling cue ball. The first row has considerably larger values than the other two, and the first column similarly higher values. What's this mean? The first row is telling us that some angles have a little bit of CIT and others have quite a bit. And the first column tells us that there's a lot of variation in CIT when there's stun compared to when it's a rolling cue ball across all speeds. Now, let's look at having a shot and changing its shot speed. We'll separately look at stun versus rolling and see how much change in CIT angle we'll encounter. This is like a situation where we're going to shoot a shot and we're not sure for position. Should we shoot slower and hold the cue ball, or should we hit another rail and go for position on the other side? How much will that decision affect how we have to aim the shot? We're fine with a 3/4 ball hit shot, but all of the others certainly have issues, stun more so than the others. Now consider varying the cue ball vertical spin, anywhere from draw to stun to normal roll. This would be like we're changing our mind or considering changing our mind about what ball we're playing position for next, say an 8 ball or in straight pull. How much change in the CIT angle would there be, and thus how much do we have to consider changing our aim for the shot? Well, for a 3/4 ball hit, I'd say at all speeds there. Half ball hit, very slow and medium. Quarter ball hit, only one very slow is an issue. But if we're considering playing position on different balls, would not only change the spin on the cue ball, but would change the speed. So if we look at any speed in any cue ball vertical spin, suddenly all the cut angles are a problem. We would have to reevaluate our aim for the shot in all those circumstances. This is not good. So let's look at an example. Here the 9 balls set up a fairly long shot. It's a 30-degree cut, and I'm using the aim right CIT adjustment, and what I've done is set it up for the average of 2 degrees of cut-induced throw that I expect. When I shot slowly, or excuse me, medium speed, I made the shot. Now these two at high speed missed. At higher speed, the shots go short because there's less throw. Now I slow down a bit, there's a little bit more throw, and I pocket the ball. Now, what about all those numbers? Where did they come from? Well, they're the result of analyzing the raw CIT numbers published in my document, Data for Advancing Players. That data, in turn, derives from the work of Dr. Dave and his technical proofs. He has a graph of CIT versus angle at 3 shot speeds, like 3 miles per hour, for example. I couldn't read the chart accurately enough for my purposes, and I didn't know what 3 miles per hour is on a pool table, and thought you wouldn't either. So I used Dr. Dave's equation to make a spreadsheet and computed throw for each of my 16 angles. And then for speed, I wanted something we could all easily understand. So the speed corresponding to 6 diamonds, that is head spot to foot rail, is my very slow speed. 2 rails, the lag shot, is my slow speed, and so on up to 5 rails, my very fast speed. So let's wrap up. Cut-induced throw causes shots to go long, up to 5 degrees, but normally under 2.5 degrees, which it can be a big deal in some situations. Sliding friction between the balls is the cause. You've probably learned to automatically compensate your aim for the average throw on a shot, but that gets you in trouble on some shots because you don't know the real aim and how to adapt for the angle, speed, and less common spins such as inside English, or even just slow stun. You need to learn to identify the situations where it's an issue and adjust. We'll cover that in the next video, as well as discussing ways to adjust. And you'll learn about the AimRight version 3.0 with CIT practice setup capabilities, and a document, Data for Advancing Players, which gives you the CIT data you'll need for a disciplined learning experience. See you then.